All right. So, we're going to go ahead and in preparation of moving into our game engine here in, I don't know, what, 3 or 4 weeks, we're going to go back to our dungeon crawler, get our mind out of recursion a little bit. Hopefully, everyone saw recursion is doable, but difficult to wrap your mind around. The more times you run into it, the better practice you get. Some of you will have the language theory class later on in your um, studies where you'll learn, you'll only be able to do stuff recursively since the programming language you use, Scheme, only supports, doesn't support loops. So I think it'll all kind of come together, but understand that typically learning merge sort, well, really, we choose merge sort because it's implemented recursively, is always difficult. It's supposed to kind of be that set point, and then you'll probably run into it again in a different context next year, and it'll feel less difficult. You'll run into it in a different context the year after that, and eventually it'll feel like, oh, that isn't that big of a deal. So if in the end you followed, even if you have to go back through the code, I did put it up on Slack, what we looked at for the result last class. If you feel like you could walk through that and understand what's going on, I would say that's good enough for right now. It is going to be difficult for most people to write things recursively for a little bit. So that's okay. I won't be testing you specifically on things like merge sort. I might test you on something recursively, but it would be a much smaller problem. So, like, kind of the famous first recursion problem or small recursion problem might be like factorial. So, like, 4 factorial is 4 times 3 times 2 times 1. So, 4 factorial is actually 4 times 3 factorial. 3 factorial is 3 times 2 factorial. 2 factorial is 2 times 1 factorial. And 1 factorial is 1. So if you just kind of want to see that here real quick in code, if we write factorial, and this takes in an integer n. So for example, this might be the factorial of 5. If I call it up here, I'll just say factorial, passing it 5, like that. 5 comes in as n. We would say if n is equivalent to 1, we can say return n, and else return n times factorial n minus 1.
Factorial or like the actual factorial?
Well, factorial is the name of the function. So the integer I'm passing it in this example is 5. So I expect this to give me the result of 5 times 4 times 3 times 2 times 1. The logic to accomplish that recursively looks like this. No, I mean, actually, most languages probably have in their math library a factorial. I'm not positive, but this is something that you should be able to write. 5 lines of code. Not a whole lot of stuff going on here, but this is a concise example of recursion for a problem that isn't an overly difficult problem. If somebody says, what's 5 factorial? You can say, oh, 5 factorial is 5 times 4 times 3 times 2 times 1. That's the math of 5 factorial. But you can write it recursively by just asking, if the current value of n is 1, return it. Return 1. Otherwise, return whatever the current value of n is times call factorial again on 1 smaller than n. So the first time through, this would be return 5 times whatever the factorial of 4 returns. That gets put on hold. It can't finish until it gets the answer from that guy. The next time through would be return 4 times the factorial of 3. Then the next time, 3 times the factorial of 2. 2 times the factorial of 1. And finally, that guy returns the 1. which then allows the previous guy to finish, which lets the previous one finish, and so on and so forth until you finally get your answer. You could also write factorial iteratively, right? You could say static int factorial 2, let's say, takes in an int n. And maybe this guy is just a for loop for int I is equal to n. I is greater than 1. I minus minus. Maybe we say int answer is equal to 1. We would then say answer equals answer times I. And in the end, return answer. So if n was 5, start answer off at 1, start I off at 5, keep going as long as I is bigger than 1. You can go to greater than or equal to 1, but 1 times anything will be that value. Decrement by 1 each time. First time through, answer is equal to 1 times 5 by our current example. So answer is currently 5. Next time through, answer is equal to 5 times 4. Next time through, answer will be equal to 20 times 3, so on and so forth. So this will return the same result as this guy down here. Right, so factorial is a good, I would say kind of a too simple solution for recursion for a long weekend homework assignment. That's why we needed to hit merge sort anyways, but I expect this to be easier to wrap your mind around than merge sort. Merge sort's 1-2 punch is really that you have 2 recursive calls. But as soon as you understand that, oh, a recursive call just means I need something that knows how to calculate factorial in this case. So what do? I call factorial. In the other case with merge sort, well, I have to merge sort the left half. I need to merge sort the right half. That's 2 separate calls to merge sort. One for the left half, one for the right half. For each of those, I need to merge sort the left half, merge sort the right half, so on and so forth. So it's not like this, the 2 calls is some sort of magical exception. It's just part of what the merge sort algorithm demands. If we were to write merge sort in a multi-threaded way, it actually isn't tons more code. We'd already looked at threads enough to kind of create some communication between threads. So now what we would do is we would put the merge sort function inside of a thread. And whenever we needed to sort the left half and sort the right half, we would spawn a thread for the left half. We would spawn a thread for the right half, tell both of those guys to start. And then the parent, the one who spawned those threads, would just wait for those 2 to finish, because then he knows that his portion of the array has been sorted. So it's not significantly different logic. The advantage we got with threads is rather than dealing with the inefficiencies of recursion, which has to put stuff on hold, which takes up a lot of memory, we had multiple threads, each working on their little part of the list that needed to be sorted. All right. So we will incorporate some threading into our dungeon crawler dealy flippy thing. Here, I'll save this and I'll grab the link. Just keep in mind that the code for factorial is there at the very bottom if you're interested in looking at that. So factorial example is at the bottom of driver here. All right. So now let's go and remind ourselves where we left off in our dungeon crawler. We just got to the point, or at least this code base shows that we were just getting ready to look at rooms. I think that was the assignment I tried to give during finals week, if I remember correctly. These classes need to meet 5 days a week for 2 hours per class. Wouldn't that be better? I can't mentally handle that. All right. So what are we doing currently? Our driver creates 2 instances of player, What is a player? So we just have a whole bunch of Java classes here. What's a player? We've decided a player has a name, a number of hit points, a strength, and an armor class. To create a player, we just pass in the name, it sets the name, and then rolls some dice to generate these other values. We just kind of pie in the sky decided hit points is some value between 0 and 16 plus 4 plus 14 to give you a starting point for hit points for no rhyme or reason. Just you get a decent chunk of hit points. Strength, some value between I guess it'll end up being 7 and 12, so on and so forth. For armor class, we just created some statistics for these guys. A player is able to report whether or not they're dead. So this just returns whether their hit points is 0 or smaller. A player can take some damage, so we pass in an amount of damage that they should take, and we just reduce their hit points by that amount of damage. So all these are small little functions that don't do a ton. We're just reminding ourselves what things we have built so far. Get armor class is just the getter for these protected fields. Remember, public, private, protected. Private means it's only accessible inside of player. Public means it's accessible anywhere in your package. Protected means it's accessible inside of player as well as children of player. For instance, we created a fighter, which extends player. We also created a wizard, which we didn't finish differentiating from player yet, but that's the thing that exists. In fact, for the moment, just so we can get into this a little bit, we might even forego this wizard fighter thing for a second and just have players and kind of monsters floating around our thing, but we'll deal with that in a little bit. All right, so we have getters for all those things in case a class that isn't us or isn't a child of us needs access to some of these things like our armor class or something like that. So we have a getter for our armor class. We have a getter for our name. And then a player can display themselves, which just kind of spits out their current statistics, a snapshot of their health type thing. All right. So if we do nothing else here, just comment out a couple of things here. Probably should have done a multi-line comment there, but damage is done. All right, so for right now, I'm creating 2 instances of player. I'll tell each of these guys to display themselves. And we should get that weird looking square thing that shows our 2 players. Here's Mike, hit points of 15, strength of 8, armor class of 11. Here's Dave, hit points of 25, strength of 9, armor class of 10. I think a pretty high percentage of the time Dave's going to win that fight, but we'll see what happens. But in any case, that's what our player currently does. Houses information about that stuff. We also created a dice class. Our dice class is just a simple way of generating random numbers, kind of as if we're trying to mimic old school tabletop role-playing games before we had our video games. Old school was we had MUD, so we're kind of writing something called a MUD, multi-user dungeon. The newer versions of these would have been like things like World of Warcraft, Final Fantasy, those kinds of games. So we're pre-graphics here. Once we get to the game engine, we'll be integrating some graphics, but anything we do in here will be crappy graphics. If you want to get fancy with it, that's up to you. It'd be awesome. We've had some really cool things done. Don't expect me to make it look cool. We're going to have our dude represented by like a sphere, a single color sphere. So we all have various talent areas. So as good as I might be at programming, I'm equally bad at art stuff. All right. So our dice class here allows us to create a die of a certain size. typically, you have D4s, D6s, D8s, D20s, D10s, D12s, whatever it is. We create our random number generator. We set the sides in the constructor, and then we gave it a method just called roll that returns a random number between 1 and the number of sides inclusive. That's all dice does. Build a dice, roll the dice, give you a number between 1 and however many sides the dice had. All right. And then what we were doing is we had this idea for testing these things. We had our arena where we were basically just having our players try to kill each other, right? And what our arena did is took in a couple of players and also some dice. So the constructor needs 2 players in order to work. So we saw that happen kind of out here. So here's our arena. We passed in our P1 and our P2. And then in the constructor for arena, we also went ahead and initialized our 20-sided die for doing our attack rolls or whatever, common for old Dungeons and Dragons stuff. We have a function called start fight. Start fight just decides that player 1 gets to be the current attacker and player 2 gets the current defender. You can always randomize that if you want, but we just decided that's how it works. We also created a 4-sided die. We'll see what we use that for here in a second. Then we created an infinite loop. We basically want to have these guys keep trying to beat up each other until somebody keels over. We tell both of our players to display themselves initially. So if we go back to driver here, I no longer really need to display ourselves here because that's going to get displayed at the very beginning of the fight. So see, after we create our arena, the very first thing we do is we call start fight. Start fight comes into right here, sets player 1 as the current attacker, player 2 as the current defender. We get a 4-sided die. We decide we're going to do something forever until something unnaturally breaks us out of this loop. We tell both players to display themselves. Instead of using current attacker and current defender to display themselves, I displayed P1 and P2. That way it's always in the same order. We can keep track of seeing one guy's health dwindle and that kind of stuff instead of them flipping, flopping places each time through. Choice. We went ahead and rolled our D20 for our attack roll. We compare whatever we rolled with that D20 to whoever the current defender's armor class is. All right, if you look down here, for instance, Dave has an armor class of 10. Mike had an armor class of 11. So we're going to generate a random number between 1 and 20 and check to see, is that greater than or equal to the armor class? If it's greater than or equal to the current defender's armor class, that means we're going to hit them. So we try to hit them, determine if we hit them by that armor class thingy. And then if we get into this if statement, that means we have hit them. We need to decide how hard we're going to hit them. That's where we're using our D4. So we go ahead and roll damage, getting some amount of damage between 1 and 4. Then we tell our current defender to take some of that damage. We'll take all of that damage we just rolled. So remember, we saw that in player. Take damage here. It's this guy right here. Takes in a number and just decreases the hit points by that number. All right. Then we ask the question. We know we just hit the defender. We know we've applied the damage. Now let's check on him to see if he's still alive. Okay, so if our defender has now died as a result of our last strike, then we're going to print out whoever the current attacker was name, say they won the fight because they're the ones that just struck the defender, and then we'll break out of our infinite while loop. If the last attack did not kill them, we will end up spinning back up. That's what happens in the event that we had a successful strike. In an unsuccessful strike, we give a little feedback saying that, whoever the current attacker is swings and misses. That's because their roll did not clear the armor class. Then we deal with this kind of thing, and that was a thing in tabletop role playing called a critical miss. So if they happen to roll a one when trying to attack the defender, that means they kind of like tripped over their sword or something, and uh, in some cases you do some damage to yourself or something. I don't think we did that. We just put a little commentary out here. So if you critically miss, we say critical miss. The name stumbles and stabs themselves on the foot. We don't actually have them take damage, although I guess we could, but we didn't. All right, so this else is what happens when we didn't hit the defender. This if is what happens when we did hit the defender. Any way you cut it, if we're still alive when we get to this line right here, which we would always still be going if we got into this else, but we situationally would be going if we got into the if, because we may have killed the defender. Okay, so if we kill the defender, we're going to be breaking out of this loop immediately, which gets us out of this while loop, which means we will never get to this line of code. All right, but if, regardless of whether we hit him or not, if everybody's still alive, we'll get to this line of code where we go ahead and swap the current attacker and the current defender. They just switch places so that the next time through the loop, the other guy is trying to hit the other person. All right. Do that forever and ever and ever until we finally exit out of the loop. We could always do like a system.out.println game over or something like that in there. All right. So out here in driver, create two players, create an instance of arena, tell them to try to kill each other. Go ahead and run this. We see Mike won the fight, game over. We can scroll through and kind of see how it all went down if we wanted to. You know, these are the multiple rounds that happened. Actually, it took a while. Had a lot of swings and misses. Ah, Mike had a armor class of 16. Mike was tough to hit there. It's armor classes, and this is not a programming term. This is Dungeons and Dragons nomenclature. So anybody who is, let's say, plays tabletop Dungeons and Dragons, I'm not sure if that's cool or not cool, but you'll know what I'm talking about. It's not important that the rest of you necessarily follow this. You will not be tested on this, but AC stands for armor class. It effectively means how tough you are when somebody swings at you. Can they hurt you? Is what it effectively means. No accuracy in our current small version. And still in our model here, I mean, this is very dumbed down to the rules of the D20 gaming system, which has more stats, has intelligence and dexterity, and these things give bonus rolls to, like, you know, who goes first type things, rolling for initiative. We're not going that deep into this. Right now, it's kind of both guys have some armor on, their some level of difficulty to hit. We try to hit them, we do some damage to them, keep going back and forth until somebody keels over, just as an example. Go ahead. You were
I
saying?
was gonna say, like the die is basically kind of like the accuracy, because if you think about it, like if you get a low roll, then
Yeah, the rolling the D20 to see if you hit is kind of like their version of taking a swing and seeing that they hit the baseball. Yeah. All right, so that's the current state of things. So now what we want to do is we want to kind of replace this arena. Not that we won't use some of the aspects of this arena. We might go back to it to have fights when, you know, we do encounter something. But what we want to do is we want to kind of create a map. I think we had stopped here. So we had this idea that we have a bunch of rooms, and these rooms are linked to each other in some way. All right. So for right now, what we're going to do is we're going to have rooms just have a name. Well, a name and maybe a couple of other things, because they'll also have a collection of who's here, what players are also in the room. All right, so let's look at room here. For the time being, we're just going to ignore fighter and wizard. Yeah, we just started working on fighter and wizard. That'll be version 2 of our game when we want to start specializing players. But for right now, let's move forward with just generic players. All right, so we started writing room here. Now remember, I've put this code in there where I say room extends object. Remember, whenever you have a class in Java, this is hidden from us. We don't have to put that there. It works with it there. So we proved that that stuff is there. But if you're writing a class in Java, you would probably just say classroom. It is implied here, since you didn't specifically extend any classes, any other classes, that this guy will extend the generic object, the top level object in Java. All right, and we're going to go ahead and say a room has a name. And then we're going to have our constructor, public room. I need smaller fingers. This dot name is equal to name. All right, so that's what a room will be currently. Maybe we teach rooms to display themselves for whatever reason. So we say public void display. And maybe we do something like system.out.println room. This dot name. Something like that. All right, so generic room, here's our field. We remember one thing. Here's how we build one of these guys currently. And then we just say they're allowed to display themselves. So if we're trying to make this a reality, we're going to create 6 rooms. Maybe calling them R1, R2, R3, R4, R5, and R6. Let's start with that. Go back here to driver. I'm going to go ahead and kill off our arena, not use that currently. We'll keep our players there. We're just not going to really use them quite yet, but pretty soon. So now we're going to say room R1 is equal to new room. We'll call this guy R1. We'll do that 5 more times. R2, R3, R4, R5, R6. Ay, ay, ay. Date our strings. Ay, ay, ay. Hey, now if we run this code right now, what will the output of this be? Am I ever actually displaying any of the rooms? So right now I'm creating instances of player, doing nothing with those. I'm creating instances of rooms, doing nothing with those. They all exist, but I'm not using them. So if I want those rooms to display themselves, I would have to say R1.display, something like that. You mean build it into the constructor? Well, you could, but that means every single time you create an instance of a room, it'll display to the screen, which maybe works for some applications, but I would probably say if you're building your map, you maybe don't want to have a whole bunch of output to your screen as you're building it, but nothing keeps you from saying this dot display in here for debugging purposes. And then later on, when you don't need that anymore, you just comment it out. Well, the constructor for a room only gets called 1 time. So in our case, it'll get called 6 times, once per instance of room. So go ahead. Well, we did. I mean, we built this function called display, but if you want it actually to display itself something, it has to be called from somewhere. So we can call it during the time the room is being built if we want to, or we can call it externally, like I'm doing here, where I'm saying I'm building the room right here. We're currently building that room. Does not do anything output wise. It just sets the name. And then if I want to test that room to make sure the stuff got set right, I then have to say R1 dot display, call your display function. Okay. But now to your point, which is actually for what we're doing here, a decent suggestion, we could say this dot display in our constructor. If we just want to prove that these things were getting built right, by doing that, we then don't have to individually display it. We're just going to say, look, I'm going to build 6 rooms. As they're being built, each one is going to spit out some information about themselves. I don't want that to be in my final game, but for right now, I want to see that. So later on, to remove it, you just comment this out or get rid of that line. But for now, it'll give us information. So this probably is better for us at this exact point than having to write 6 more lines of code for just testing purposes. All right, so now our output will be, room R1, room R2, room R3, because the constructors for all these guys print that out. All right, so now we have some rooms. Now, rooms need to also now connect to other rooms, right? Because if we look at our map here, we're saying, hey, I have 6 rooms. The way we've laid this out is in the form of a cross here at Concordia. So our dungeon is shaped like a cross, and there's going to be massive killing done inside the dungeon. So we got to play both sides of the coin here. But the idea is that maybe we load some players into this room, and then they're able to traverse through our map, going into the different rooms, walk around in the map. So maybe initially we say our dungeon is something for a single player. All right, so that means that every room potentially has a player in it. So we'll go into our room. We're going to add an additional field. Maybe we call that guy the player. Now, when a room is first built, we'll set this dot the player equal to null. There isn't a player in there. This would have been the default value for that field, but I mentioned last semester, it's not great programming practice to rely on default values for types. So in this case, if I don't actually have a player to put into my variable called the player, I should explicitly set it to null rather than just let the default value set it to null. We will be adding a player soon. All right, but it's not happening at the time that the room is created. The reason for that, if we think about this map here, maybe this ends up being our dungeon entrance, R1 or something like that. And we intend to only put player 1 into R1 maybe. We don't want to have to add a player to every single one of these 6 rooms as we're building it. And now you have the same player in 6 places or something like that. So it's not so rooms can be built before somebody walks into it is the idea if we're mapping this to kind of real life. So we'll go ahead and say the player is null. We only need the name of the room to set it, but the player is private. So we probably want to give ourselves a setter the ability to add a player to the room. Okay, so maybe we say public void set the player. So in here, we'll just say this dot the player is equal to the player. We could put in some checking there, making sure we're not overwriting some other player or something like that. But for right now, we know we're only going to throw a single player into our dungeon. So whenever we decide to put a player into the room, this is how it's going to happen. Go ahead. Yeah, correct.
Usually play nice with computer stuff, right?
Yeah, and the thing is, you're absolutely right. So if right here, if we said this dot the player dot display, something like that, right after we set it to null, if we try to tell that guy to display itself, we're going to get some not great results. It's going to get a null pointer exception as you're pointing out here. So here's our null pointer exception because we tried to call the display method on something that doesn't exist, on nothingness. All right. So probably don't want to call that when we absolutely know it's null. Put a little comment for testing purposes as the room is built. All right. Now we're probably going to be updating our display function here because displaying the room should show its name, but it also should show who else is there. Right? So maybe we do a system.out.println. Maybe we go also here, something like that. Now, if we just write this dot the player dot get name, for example, which is how players can report publicly what their name is. If we just do this, as she pointed out, we risk something. We don't know if this player has a value in it. In fact, we do know for a fact when display gets called right here, when it's being built, we know that player does not have a value in there. This will be another null pointer exception. So we really want this guy to only get a name if the value is real. So I'm going to show you what I would consider the good way of doing this, but then I'll show you another way that you might like. So we're going to say if this dot the player is not equal to null. That is, if it's a real value, then we know we can safely do that. Otherwise, not that I know of. I mean, I would think the restroom would be the closest place to get some Kleenex. I'm not sure if there are, grab them. All right, so if we get into an else because the player is not equal, because the player is null, then we're just going to say also here nobody or something like that. We won't try to access the value here. All right, so now we've made our display function safe for this, given the fact that players are likely going to be null often, except for a room after we put a player in there, which we haven't actually done yet. So now we can do this and all our rooms will, forgot my semicolon at the end of this line, which means I also did it there. So now all our rooms say nobody's in there. So I mentioned that there is kind of another geeky way of doing this. Just put it right before here, something called an inline if statement. It's left over from old C programming. And what we would do here is we would do that, followed by a question mark. Just ditch this code for a second. And let me that. So we're saying also here, we ask a question. I'll probably put this in parentheses too. So this guy is a Boolean expression. If this dot the player is not equal to null, it will boil down to that value right there. If it is equal to null, it boils down to this value. So an inline if statement allows you to have a Boolean expression followed by, it actually doesn't have to be a single line if you want to shove some curly braces in there, but allows you to, in a single little snippet, decide, do I want to try to get the name or do I hard code the name to nobody? We run this real quick. Should see it still works. Where did I put get name? What are we talking about? Right here? That's from player. So this dot the player is an instance of player. So we would look inside of player for get name. Incompatible types. What have I done? I have to put this entire thing. Oh, I didn't finish my closing parenthesis. No, I did. Doesn't seem like it should make any difference. I guess it really wants the whole thing to be self-contained in parentheses. So we see here that this has the identical effect to our much clearer if statement, with the exception of I didn't have to have two system.outlines, one for each version of this. I would encourage you not to write it this way. Yes, it looks geeky. There are every now and then situations where it actually is pretty convenient. I would argue this might not be one of those. So I'm going to copy this here. I'll put it back in as a comment. This inline if statement example. So now we just have a regular plain Jane if statement. If it's not null, print his name. If it is null, just put nobody there. Much more straightforward. Okay. Make sure this guy still runs. All right. So now what we're going to do is we are going to connect these. Well, we're going to start thinking about connecting these. So what we're going to do is we're going to say r1.add, I call it add player. Set the player is what I called it. So R1 set the player. We'll just put P1 in there. And then we'll say R1 display yourself again. So the first time through, all of these rooms have no players in them. But then we added a player to the first room, told it to display itself. We should get Mike now showing that he's in that room. Okay. So now we have to think about how do we connect rooms to each other? How do I let room 1 know that to the north we have another room 2? How do we let room 2 know that to the south we have room 1, to the north we have room 3? How do we let room 3 know that to the south is R2, to the west is R4, to the north is R6, to the east is R5, so on and so forth? We want to actually have these rooms connected to each other. So up top here, we could have a list of rooms that this leads to. So the thing we're going to be looking at here is, well, why don't we actually put in a collection of exits? So we're going to say private available exits. And because we're dealing with north, south, east, west in our example here, the most number of exits we can possibly have is 4. So this will be a new, sorry, we haven't written exit yet, but this will be a new exit array of maximum size 4. I'm going to have another variable, int cur number of exits, start that off at 0. When a room is first built, it has the capability of holding up to 4 exits, but we don't actually have any exits in there. So we're going to keep track of that. Inside of a room, we're going to build a function called add exit. That takes in a string direction and takes in a room destination. Now, inside here, we want to be able to create that exit, add it to our list of exits. So we would say exit E is equal to new exit, passing it direction and passing it destination, like this. Now, this assumes that we have built a class called exit, which we have not yet. Guess what your homework assignment is going to be. All right, but we'll give you initial start for this. So we have exit.java. We'll have public class exit. And when we look at room here, we see that we expect our constructor for exit to take in a string and to take in a room. So this guy will have a private string direction, a private room destination. We'll have our constructor here that'll take in a string direction and a room destination. This guy will set this is direction equal to direction. This dot destination equal to destination. So we've built a truth into this now. We've created an exit. Not quite what an exit will ultimately be, but we've created an exit such that when we try to add an exit to a room, it will create this new exit, passing it the direction and the destination. It will then say this dot, call it available exits. Available exits at position, this dot current number of exits is equal to E. And then we'll increment current number of exits. So to add an exit to a room means to pass in the direction and the room you want it to lead to. We'll build internally an instance of our exit object. We will add that exit to our number of exits, or to our available exits, and then we'll increase our current number of exits. So if we did a north, south, east, and west for this, current exits would go from current exit number would go from 0 to 1 to 2 to 3 to hit all 4 of them, which are the legal buckets in this 4-element array. We could, if we wanted to put a little protection here, we could say that we're only going to do this if this dot current number of exits is less than or equal to 3. Since we're the ones who are writing this code, the hope is that we don't try to call this on more than 4 times for an individual room, but now we've protected against that. What's in there? System.err.println. I see the time. There are too many exits. All right, so I'll put the assignment up here in a few minutes. It will be to finish implementing this to match up to what I'm going to have in main. All right, so I've given you a starting point. Now you got to make it work by piecing all these things together. Okay? I will see everybody on Friday. You kind of will. I mean, that's kind of the direction we're going to go. What we would probably do is store the information about our map in of a JSON document that lists basically some creative person designed the map. We then have a small program that turns their little design into a JSON object that our program then reads in and makes all this true. Rather than hard coding, here's room R1, R2, R3, it would just read in JSON and do it. Yeah. And we will look at that. We just haven't gotten to the point where we can deal with JSON yet. Yep, take care.
So I'm still a little on the edge about the exit. So exit is like what we're gonna write for when we leave the room. But like I'm a little bit.
Well, ultimately, and for this assignment, you won't have to actually have a player go it through the exits yet.
Okay.
But for this assignment, the idea would be is after I've added the exit leading to R2,
Yeah.
if I tell R1 to display itself, it would say something like, room R1, also here, Mike, available exits or obvious exits, whatever, R2. It would show that this guy is holding on to exactly one exit. So in his array of exits per room, our room has this array of exits that after we add one exit, that value would be 1. It would then display the name of the room and the direction it leads to that it goes. Actually, you don't even have to have the name of the room. It probably would just say available exits to the north.
Oh, okay.
So with the idea that if a player then wanted to go to the north, once we have our thing asking the player what do they want to do, when they type in north and press enter, it would then take that exit, which would remove them from the room they're currently in and put them into the destination room.
Oh, all right.
Make some sense? Okay, but that's not going to be part of that. This assignment is the setup for that.
Okay.
So this assignment is just add all the right exits, prove that the exits got added in. So when you say R1 dot display, it would say there's a room to the north. When you say R2 dot display, it'll say there's a room to the south and to the north. R3, north, south, east, and west, so on and so forth.
Got it.
Got it?
So much. Yeah.
Yep.
They're understanding.
All right. Take care.